Welcome to the video from Chapter 7, Lesson 3, Triangle Inequalities. This video will answer the essential question, how are the angles and sides of a triangle related to each other? In every triangle, the small side of the triangle is opposite the small angle. For the large side is opposite the large angle every single time. So let's use that information to list the angles from least to greatest. Now, if you notice in this example, it's asking about angles, but we are only given side length information. So what we know based on the relationship from the sides and the angles is that if I take the smallest side, that will be opposite the smallest angle. And so I'm starting with the smallest because it's asking for from least to greatest. So I know that angle A is going to be the smallest angle because it is opposite of that smallest side. Then I would go to the next one, 20, and find the angle that is opposite of that, angle C. And then finally, 22, that side is opposite of angle B, which means that it is the largest angle. So listing from least to greatest, angle A is the smallest, then angle C, and then angle B. In this example, it's asking the same thing, following the same principle. We're going from the least to the greatest. So I'm going to find the smallest side, and then I'm going to figure out that opposite of that would be angle D. So that will be the smallest angle. Then the next side is 5. And this one is a little tricky just because, like, okay, well, opposite, it's kind of going straight out. There's no angle there. There's just the side with 6. So you really have to look at which angle is creating this side, kind of like a flashlight. So we're down here that F is actually the angle that is creating this side. Like it's like a flashlight shooting this beam, creating this length of 5. So the 5 is opposite of angle F. So angle F is the middle angle measurement, and then 6 is the largest, and that is opposite of E. So from least to greatest, it's angle D, angle F, and then angle E. We'll use that same relationship to figure out the sides from least to greatest, but notice again in the picture, it's asking for the sides, but we're given the angle information. So I do the same thing. If I want the smallest angle, the smallest side, I'm gonna start with the smallest angle and look opposite of that. So opposite of angle Z is side XY. So that's going to be the smallest one. Next largest angle would be the 60 degrees. And so that is going to go with the XZ side. And then last, the 62 degrees is giving the largest side, which is YZ. Now, it looks like in this particular triangle that we have an equilateral triangle and equiangular one, but you can't trust the picture. You have to go based on the information that is given. And you can see that these are all within, 2 degrees of each other, 2 to 4 degrees of each other. So it's going to look very close to an equiangular triangle, but it is not. So these sides may be very close together, but XY is the smallest, working our way up to YZ, which is the largest. Same process for this example. The only difference is that we don't have this particular angle labeled, but this is a right triangle. So I can take the 90 degrees that are left and subtract 37, and I'll get 43 degrees. So this angle in here, angle M, is 43 degrees, which will help me to figure out that starting with the smallest side, I'm gonna go with the smallest angle. So that will be side MT. And if you're calling it TM, I know I didn't mention this in the previous example, that it doesn't matter if you label it MT or TM because it's just a segment in this case. And moving along then, angle M is opposite of side TZ. So that's the middle. And then last will be that right angle. Going opposite of that would be the hypotenuse. So that's side MZ. One thing to consider when we have right triangles, the hypotenuse, the side opposite that 90 degrees, should always, always, always be your longest side because the 90 degree will always be the largest angle. So the side opposite that, the hypotenuse, will always be the longest side of the triangle. Now let's go ahead and get into some examples that actually have variables in it. We could go ahead and solve for x, knowing that the three angles, the sum of the three angles together is equal to 180 degrees from the triangle sum theorem. However, I'm not going to do that with this particular problem because this is just twice some x value, 4 times that same x value, and 3 times that same x value. Because, and this is the only example that's going to work like this, because they all are just 2 times the exact same variable, or 4 times that, or 3 times that, then I know that this is going to be the smallest angle. This 2x is going to be the smallest angle because it's only 2 times whatever that x value is. X could be 20, okay? I don't know, but let's say that it was 20. Then this would be 40, this would be 80, and this would be 60 because it's 2 times that value, 4 times that value, and 3 times that value. Whatever the value is, because it's only being multiplied by 2, that's going to be the smallest side. So Gn is going to be the smallest side. Then 3x is going to be the next smallest angle, so that's going to give me side Bn. And then lastly, the 4x is going to be opposite the largest or the longest side, which is Bg. So I don't actually have to go through and solve for the variable in this case because it's just being multiplied 2 times, 4 times, and 3 times. This example, however, we will need to solve because this is 7x plus 10. This is 9x minus 3. They have these addition and subtractions on them that is throwing everything off. We can't just look at the multiplier in this case because there are sums and differences here. So with this one, we don't have a choice. We have to add the 3 angles together using the triangle angle sum theorem, the fact that there are 180 degrees in a triangle, and we need to add them together to set them equal to 180 first to find the value of x. So after simplifying by combining like terms, starting to solve using inverse operations, I finally get down to the point that x equals 7. And now what you're going to see happen is I'm going to take that x value and plug it in to each of these expressions to find the degree or angle measure for each of the three angles in the triangle. Now that I have that figured out, name the largest side of the triangle, I'm going to look for that largest angle, find the side opposite of that. So SK is the largest side. And that wraps up lesson 3 about triangle inequalities. So how are the angles and sides related to each other? The small side is always across from the small angle. The large side is always across from the large angle.